Alright, this will be the first video of I want to show you how to do implicit differentiation. So, as you know that there are some functions that you cannot simply make y as a subject, right? Means that y and x are implicit, means that y is the implicit function of x. So they cannot be separated or they cannot make y as a subject. Alright, so this case happens, so we need the help of implicit differentiation. So before I teaching you implicit differentiation, I'm going to teach you how to derive some function. For example, if I have differentiate with respect to x, for example, I differentiate x squared with respect to x. This one easy, right? Because differentiate x squared, you will have 2x, right? So what if I differentiate so what if I differentiate y equals to ex, right? So I will differentiate. So as I differentiate, I will getting ex, right? As the formula for differentiate ex will be ex. So what if I have ln, right? Ln x. Okay, ln 2x minus 1, for example. So I will be differentiate, as you already understand all the formula, right? Differentiate exponent, ln, all the logarithmic, exponential function, and trigonometric function, right? So, okay, let's see this one. You have 1 over 2x minus 1. Differentiate 2x minus 1, you have 2, right? This is explicit. Differentiate explicitly. So, which that there are no y inside. You see that there y equals to ex. This is y equals to x squared. So it's y equals to ln 2x minus 1. So this is a y is writing in the explicit function of x. So now let's say what happened if I going to write this to be differentiate y to the power of 2. Right? It's the same. So this one is differentiate x squared with respect to x. They have differentiate with its own, right? So this one is differentiate with respect to differentiate y squared with respect to x. So what you do will be same thing. You are getting 2y. Differentiate y squared, you're getting 2y. But you just add another dy dx here, right? So it means that you differentiate the y squared and you differentiate the y inside there. It's just like using chain rule, right? It's a chain rule because you differentiate, you bring down the power 2, and the y, the 2 you minus 1, you're getting 1, right? Getting 1. Then you differentiate the power, differentiate the function inside there, dy dx. This is called implicit differentiation. So for example, this case here. So what if you differentiate ey, right? You differentiate ey. So as usual, you differentiate ex or ey, you're just writing back the ey, right? But for this case, you have to differentiate the power. It's a function. It's a y is like fx, alright? It's like fx. So differentiate, so you have to dy dx. That's the meaning here. So for example, these cases here, so you have differentiate ln. Differentiate ln 2y. Instead of x, differentiate x, but now it's y. So it will still be the same, 1 over 2y minus 1, right? Differentiate 2y minus 1, you have 2, right? 2 dy dx. Don't forget, because 2y, you differentiate, you're getting 2 dy dx. So differentiate negative 1, you have 0, right? So let's go for more examples. You must be familiar with this before I teaching you how to do implicit differentiation. Alright, let's continue with some examples. So we warm up first before we doing the actual implicit differentiation. So let's say we have xy to the power of 2. Differentiate xy to the power of 2. Right? So in the previous lesson, all we differentiate something with all x, right? All is x. So x, x plus 1 square, alright? X ln x, everything into x. But now there is a y here, right? So this is called implicit differentiation. So what I'm going to do now is, it's still a function, right? This is your x. So I let it to be u. And y squared, I let it to be v. So I'm going to apply product rule, right? Product rule. So now you are very familiar with product rule. So I'm not going to write what's your u, what's your v. So we directly apply it. So as you remember, the product rule is uv prime plus vu prime, right? You just remember this. So you copy back the x, right? X. V prime means differentiate y square. Differentiate y square is like differentiate x. 2y, right? 2y. But because of differentiating y with respect to x, so we need to dy dx, right? Dy dx. So this is u v prime plus with v. Okay, v will be y square. Y square. Differentiate x, then you have 1, right? So you are getting 2xy dy dx plus with y to the power of 2. So this is implicit differentiation. So let's see for more example. For example, if I have d dx, now this time is sine y to the power of 2. For example, sine y to the power of 2. So you must be very good in the technique of differentiate all the exponential function, trigonometric function, only you can watching this video. So differentiate sine, right? If you still remember that this is the angle inside the sine here. So differentiate sine, you are getting cos. So you are getting cos y square, right? Cos y square. Then the second step is you have to differentiate the power inside the sine, the angle. So it will be 2y dy dx. Remember, if you differentiate y square, you're getting 2y dy dx. But if x square, then you will just have 2x. Alright? So, now, let's say if I have cos cube to the power of y. So, what can you do? So, as usual, this is a cos cube, right? So, differentiate cos y, everything to the power of 3, means that the cos is with the power. So you have to apply the chain rule or power rule. So where differentiate as usual, 3 cos y, right? 3 cos y. And then the 3 you minus 1, right? 3 minus 1. And you differentiate cos, just like you differentiate cos x. Just like you differentiate cos x. You get him negative sine x, but now it's negative sine y. Because of this is y, with respect to x, so you need to add dy dx. So this is the way we differentiate when we differentiate a function in terms of y with respect to x. So I think that's good enough as a warm-up. So now I want to show you how to differentiate an implicit function. Alright, so let's see the first example. Alright, now very important for this part here. So you have to find dy dx. So this is an implicit function, right? Implicit function. So implicit function is a function, okay? Is a function. So is a function which relate x and y, right? They relate x and y. They are relate is an equation. So it relate x and y such that y cannot be easily, the y and the x cannot be easily means that the y cannot be easily expressed in terms of x. If you try, you very hard to separate the y. Means that the y in the at one side and the x in the other side. So you cannot. Very hard for you to express in the form of y equals to fx. So is explicit, means that all in terms of x and y one side. So this is called implicit function. So that's why we need to differentiate this type of function. We name it to be implicit differentiation here. So to differentiate an implicit function, so we name it to be implicit differentiation. Okay, let's see what I'm doing now. So I will go term by term. So you look at, I will differentiate everything here. Differentiate everything with respect to x. Alright, differentiate with respect to x. So of course, differentiate x squared, you will have 2x. That's normal. That's okay. So, but for this part here, 4xy. So I'm going to do it because we differentiate everything with ddx, ddx. We are actually doing differentiate each of the term. We are differentiate e dx square. We are differentiating 4xy. Then we are differentiating 3y square and differentiate 3. After this, I will, when I tell you that differentiate with respect to x, means that each term, all the terms here, I will differentiate with respect to x. Differentiate with respect to x. That's the meaning. Alright, so let's look at differentiating this term here. Right, differentiate x squared, you have 2x. So differentiating means that d dx of the 4xy. So how to deal with this? Because this is the mount product between u and v, the 4x and y. So I'm going to apply the product rule. u v prime, v u prime. So where your u is 4x, right? Your u is 4x and your v is y. So differentiate u, okay, u, right? Your u, differentiate v prime, differentiate v, differentiate y. So you have dy dx. Remember that? So plus with v, v is y. Differentiate 4x, u prime. So you're getting 4. Means that for this part, we are getting, we can directly writing here to be, we can write as 4x dy dx, 4x dy dx plus with y, differentiate 4. So we have 4. So we have differentiate this, right? Done. So now go for differentiate 3y squared. Differentiate 3y squared with respect to x. So 3y squared. So as usual, 2, 3, 6y. 2 minus 1, you have 1. So then you dy dx. You're writing a dy dx. So that's all for this left hand side here. Done. So differentiate 3 is a constant. Differentiate constant, you're getting 0. So I have already done my implicit differentiation. So now my job is to rearrange such that dy dx one side. So because they asked us to find the dy dx, so I group this one and this one together because both of these we have dy dx. So I'm writing 4x dy dx plus with 6y dy dx, right? The one without dy dx, for example, this one, you see, 2x, 4y, without the dy dx, so we move it to the right hand side. So it will become negative 4y, positive, negative 4y, negative 2x. So dy dx is a common factor, so factorize the dy dx. Factorize the dy dx. So you will have 4x plus 6y equals to negative 2x. Oh, sorry, negative 4y, negative 4y, negative 2x, right? Negative 4y, negative 2x. So finally, you can conclude your dy dx here. You can say that your dy dx to be negative 4y, negative 4y, negative 2x divided by 4x plus 6y. Or you can further simplify by divided each of the term. You multiply 1 over 2 up and down. Okay? Divide by 2. So you have negative 2y, right? Negative 2y, negative x divided by 2x plus 3y. So this will be your answer for this question here. Your dy dx. This is implicit differentiation. Okay, this I consider this as an introduction to implicit differentiation. Alright, so let's go for another video. We're going for more complicated implicit function.